I want to show you how we can radically change the infrastructure we build around the world and move humanity to a more sustainable future. But first, let me introduce myself. I do scientific research on physics and acoustics, but all of this really starts back in my childhood. As a kid, I loved to build things. I wanted to solve problems, and my outlet was just to design new stuff. So little circuits and inventions. Some were better than others, and I started selling them. In kindergarten, I felt sorry for my fish, so I made it this automatic fish feeder. Fast forward to now, and my research is about giving people superhuman capabilities to sense and control their environments. But as a kid, I just wanted to create something big, solve a really important problem, like many of us. As a kid, I looked to the wider world. Around us, so much was being created and built, but were we building it the right way? Development seemed like it was going on a path that couldn't be sustained. We're building our cities around our vehicles, not the other way around. We're using maladapted vehicles and infrastructure. The future has to be different. If we look to the past to find sustainability, we see the Roman aqueducts, and they still stand because they were simple, efficient, sustainable, and they used the technology of the day. What can our civilization create and build that will last? What will be our aqueduct for the generations to come? Well, we've been building many things, but this is what it amounts to now. This is the projected climate temperature change over 100 years. It's from what we've built. 100 years from now, will we have flooded our coastal cities, caused food scarcity, mass migration, and the wars that could result? That's not an option. We need change. Energy. Our energy is still 94% coming out of the ground from things that are running out. You can track worldwide energy supply, and still most of it is coming from non-renewables. Why? Well, we need asphalt to pave our roads, and we need concentrated, dense fuel for our jets and our trucks. One of the biggest wastes is in transportation. We need to change the future of transportation. But we love our conveniences. We love flying between cities. Every time you fly in a jet, the pollution that you cause from your seat is equivalent to leaving a light switch on for an hour 500,000 times. I see a different future. We will keep on moving, but the time is ripe for a change. I see 3 changes in our future, and the first one is going to be efficiency. We need to be better at moving people at a mass scale using continental networks of mass transportation. One big engine is more efficient than 100 small engines if everyone drives separately. So we're going to need more subways, light rail, high-speed trains, and even reactivating old train lines. The next major change is going to be intelligence. Imagine an air traffic controller. Right now, they're human, but as the complexity of transportation increases, we're going to need a digital surrogate. And in fact, we've already started this. With first-in-the-world research at the University of Toronto, we're working at sensing the perception of a human driver as that perception moves through space. That's called valence flux. So we can use things like that to intelligently control vehicles. But sensors and signals can only take us so far. We need a fundamental leap forward in the vehicles themselves. We need to think big. What do I mean? Well, There exist now some vehicles that are inefficient by their very definition. A rocket has to lift its own fuel, and so does a jet. A car has air resistance. We need a true leap forward in vehicles and infrastructure to carry them. Well, that's why I've been working with a global team where we're working on a new system to bring the vacuum of space and low friction down to Earth. We're adapting an old concept called Hyperloop, which 100 years ago was conceptualized in a basic form and gradually improved, but it wasn't possible until now. Now, we've developed a significant next step forward, Transpod, where we're using aeronautics and spacecraft engineering, but the basic idea is simple. There's a tunnel, and inside the tunnel is a spacecraft. The spacecraft, Transpod, has rows of seating inside, and it carries passengers between stations at extremely high speed, over 1,000 kilometers per hour. And that's possible because it travels in a near vacuum inside that tube. Now, does that sound like science fiction? Well, we have a global team of industrial collaborators around the world, and we're collaborating with many different collaborators to make this system a reality. Now, just like in school, it all comes from the basic physics. Let's take a look. So over here, we have a scaled model of this pod that we're building. The real thing is 30 times this size. This is the front of the vehicle, this is the back. It travels in this direction. We actually have it locked down here for you so you can more easily see the airflow at the front of the vehicle. We're using mist to visualize that airflow. Now, even though the full tube we're designing is at a near vacuum inside, there's still a small amount of air, and of course we engineer for that. The passenger section is here in the middle, and they're actually two bulkheads to contain the air that you breathe. So that's just like on a jet, there's a secondary layer, bulkheads, that contain that air pressure that you breathe. So here it's shaped like this. So in that passenger zone, there's a door on both sides, and in that zone, there's a floor and rows of seats inside. Now, let's look at the overall shape. It's the opposite shape of a bullet, and that's because at the front, it looks like a jet engine, but it's not a jet engine. This is a compressor. Its job is to get trapped air out of the way that would otherwise cause friction. Now, so this friction would otherwise be caused. And let me turn down the lights, and let's turn down the house lights a little bit. Let's turn down these lights. And so you can barely see the laser that's coming out of the front of the vehicle. We're designing the full vehicle to have complete computer guidance and control because this is far too fast for any human driver. Now, we'll look a little bit closer again at the airflow here. And you can see that it stagnates. That means that it stops and goes around, if you look at the right angle. So right now it's going around. So if I start up the engine on this compressor, now I'm going to speed it up, and so now you can see the airflow changing patterns. So it makes all these interesting patterns when this compressor is started. And actually, I'll slow it down again. And so if you look at the other side again, you can see it flowing past. So this is a visualization of the flow. And I'll start that up again. And then we'll get the lighting on. And now I'm going to put the steam generator up into high power mode so we're actually able to see more of the airflow coming through. So it makes all these interesting patterns. Now, of course, the real thing doesn't have steam in it, but this is just to help us see. And so we can really go at it there. So now, compare this thing to a jet. A jet uses up most of its fuel at the beginning of the flight, when it's going up to altitude, and relatively less fuel is used after that. So if you have two cities that are spaced close together, the jet is basically going up and then down again. There's a huge amount of fuel wasted there. This completely solves that problem because here you're essentially going flat, so you no longer need that altitude change. So Transpod and Hyperloop is a fundamental improvement in the energy use. This whole thing is linked to the electrical grid, so the full tube and all the pods while they're moving. There's no fuel on board these vehicles, so they're all linked up electrically and powered using sustainable energy, actually, with solar panels. The whole tube actually has a sequence of different transpod vehicles moving along, and they're spaced at regular intervals of a few minutes apart. So this is just the classroom setup, but the full vehicle that we're designing is designed for 1,000 kilometers per hour all the way up to 1,200 kilometers per hour. Transpod is working with research centers, industrial collaborators, and governments in Europe, Asia, and North America to make this system a reality. The design is for it to be a network so that it can interface with local transit and connect out and take the pressure off of existing highways. The tube is made out of steel, and it's actually twinned for both directions. It can be elevated or at ground level or run underground in different parts of the route. The interior design, we're working on a few different configurations even than this, so regular economy class seating and business class. We're also incorporating a new way to replicate natural sunlight so that we want to make it as comfortable and enjoyable as possible. And we're working on another pod design that carries cargo. It's always been in human nature to want to move and explore. That network between cities has always formed naturally, kind of like water flow, pressure between valves, like a river. It won't stop. It's an unstoppable force of human motion, but we won't stop it. But if we can redirect that flow, we can give people a new mobility. It's faster, more convenient. If we can redirect that flow, we'll still have automobiles and jets, but where they're appropriate. We'll still need jets to cross over the oceans, and we can use cars and local transit to branch out from main central nodes, and then we can connect those nodes with ultra-high-speed trunk lines that are sustainable. Imagine someone who lives in Montreal, and she wants to go to New York for the afternoon. Now with this, she no longer needs to plan a whole weekend trip to make it worthwhile. She no longer needs to buy tickets weeks in advance. All she does is she goes to the Transpod station in Montreal, walks around New York for the afternoon, and then just takes the 45-minute ride home in time to relax for the evening. An amazing thing happens when cities are connected at ultra-high speed. We'll start to think of them less as separate cities, more as home. If you can live in one and work in another, then we'll start to get away from the economic divide between financial centers versus industrial or artistic or places of innovation. It's a great equalizer. The future of transportation will be our legacy to our grandchildren. Our future vehicles and infrastructure may resemble the trains of the past and the aerospace engineering of the future. It's on a mass scale, but it's also about personal choices. Will I, even now, will I choose a more efficient vehicle, or will I take mass transit? Or will I keep on going down the same old highway? I challenge you to make a personal choice today. Thank you.